So welcome to this new lecture. Now in this lecture we are going to see the construction details of the various other components of the battery ignition system. So spark plug we are going to discuss today, spark plug, capacitor and other remaining components. So the spark plug is located in the cylinder which ignites the air and fuel mixture. So this is the pictorial view of the spark plug wherein you are observing the center electrode. This is the center electrode and this is the side electrode. This center electrode receives the coil voltage from this terminal. Surrounding to that, you are having the hexagonal cell of the spark plug. This is the metal cell. This is the gasket you are observing here. This is the threaded portion of the spark plug and this is the insulator material. So side electrode is grounded. High voltage which is coming from this particularly secondary coil of the ignition through the distributor, this high voltage jumps between the air gap. So there is an air gap between the center electrode and the side electrode. So when that high voltage jumps over this gap, it creates the spark, and this insulator prevents the voltage from shorting to ground. So what are the functions of this spark plug? So the foremost function, it should ignite the air fuel mixture which is there inside the engine cylinder. But this is not only one function. Apart from that, another supplementary function of the spark plug is it should remove the heat from the combustion chamber. So this is the spark plug. Now, typical spark plug components already we seen. There is a terminal, this is the cell, then this is the conductive seal is there, insulator is there, insulator, this particularly insulator. So at the top you are having the ribbed insulator, at the bottom here you are having the insulator nodes. So there is a center electrode, there is a ground electrode. These are the typical components. Now first basic component of the spark plug is the steel cell which is threaded. So this threaded cell which we can screw or unscrew in the cylinder head, and the top of this it is having the hexagonal shape, so that with the help of the spark plug panel we can screw or unscrew, and this is machined. And to minimize the corrosion, its surface is electroplated with the nickel. So the steel cell electroplated with the nickel is the material for this spark plug steel cell. Now after that spark plug, another important component of the insulator is ceramic insulator. Its function is to prevent high voltage from shorting to ground, and another one, it is to remove the heat from the combustion chamber. So here you are observing this particularly ceramic insulator. This is made from the aluminum oxide and it is glazed to discourage dirt. And here it is, you are observing the nodes. Here you are observing the ribs. Why ribs are provided? So ribs are provided to increase the surface area of the insulator, so that with the help of this increased surface area, we can reduce the flash over to the ground. Also, through this surface, increase the surface area, we can increase the particularly heat transfer rate, which it is expected, because secondary purpose of this ceramic material is to remove the heat from the combustion chamber. Now, as far as electrodes are considered, these electrodes, whether it is central electrode or ground electrode, there are two electrodes, no? The central electrode and this ground electrode. These are made from your nickel alloy or platinum. These electrodes must be resistant to high temperature and corrosion. Why high temperature? Because this spark plug is coming under the very high temperature, explosive temperature, because during the power stroke, very high temperature and pressure is going to be generated inside the combustion chamber. So it must be resistance to that particular high temperature and high pressure. And the ground electrode it is welded to the cell. And here, because of this particular gap here, and because of this exhaust gases present in the combustion chamber, the electrode may get corroded. And to allow that, that is to make this particularly, here you are having this spark erosion. Spark is, that is particularly ground electrode is having the machined tip. So in between the central electrode and ground electrode, we need to provide the proper thickness, that is the proper gap. Now, as far as spark plug dimensions are considered, these are the prime dimensions which you are observing here. This is the threaded portion. So whatever the threaded portion, we are calling it as a reach. And the diameter of this threaded portion, we are calling it as a thread diameter. And with respect to this thread diameter, we are specifying the spark plug. So spark plugs are made from in 10, 12, 14, 18 mm diameter. And here between the central electrode and ground electrode, we are providing the spark plug gap. This gap must be correct. If it is too small, then weak spark will produce. And if it is too large, then the mixture will not burn completely. There will be the incomplete combustion, isn't it? And so to have the complete combustion in the combustion chamber, we need to provide the correct gap so that all the whatever the combustible mixture we are compressing in the combustion chamber, that gets burned completely. Now 14 mm out of all this, particularly 10, 12, 14, 18 mm, 14 mm is the most common size being used in various vehicles. Now here you are getting the different types, that is especially for this particularly insulator, 14 mm insulator is there, then 18 mm diameter, 14 mm diameter. So you are having the tapered sheet, there is a steel sheet, this is the short range. Short range means what is the threaded portion, it is very small. But as compared to this, if you see here, as compared to this, this is the long reach. So long reach and short reach. Then what is the ceramic insulator we are observing? This is the steel sheet we are having cell. Now, if we see the spark plug dimension, out of that one dimension is the reach. So what is the definition of this reach? Reach is nothing but the threaded portion, the length of that threaded portion. Incorrect reach can cause engine running problems or spark plug damage. So this is the cylinder head, and this cylinder is having this particularly the thickness. Through this cylinder head, we want to screw and unscrew the whatever the spark plug. So here, if I see the spark plug here.
Hello.
Yes, Jyotiba.
Sir, do एकटाच आहे मी lecture म्हणजे अजून कोण नाही.
Yes, you can continue because I have started this new one for recording purpose. So you can get connected with me. That is here the complete lecture. It will be very beneficial to you because same video I am going to upload, give you to the YouTube. Because during the regular lecture started at 4:10, it was matched because of the poor internet connectivity. So I have restarted. So you are not finding any other participants. Other participants are already left. So if you are connected, be connected, and if any problem, if you are not understanding any concept, please ask in between. Okay? Is it right? So be with me. So it will be beneficial to you. Now, if this spark plug reach is there, this is the spark plug I am inserting now. Now, when I am screwing this spark plug knows that is this particularly part goes beyond this particularly threaded, that is the thickness of that particular cylinder head. So this extended portion which is coming, because below this cylinder head there will be the combustion chamber. So extended component of the spark plug will extrude in this particular combustion chamber. And when your piston is moving up and down, this piston may cause the damage to this combustion, and that is particularly spark plug extended part. So this is called as a too long, that is too reach. If I see the another one, if you see, this is the another one wherein the threaded portion of the cylinder head and threaded portion of your spark plug are different. Spark plug threaded portion, which we are calling it as a reach, it is a compared to this cylinder head thickness, it is a less. So this is called as a short reach. Whatever earlier we seen, it is the long reach. This is the short reach. Now, what is the correct reach? Correct reach, it is nothing but the threaded portion of the spark plug and the thickness of the cylinder head, if it exactly matches. So our aim is should be have the correct reach of that particular spark plug. Now, if we are fitting this spark plug on the cylinder head, then there may be the possibility of having the space in between the threaded portion and this helical, that is your spark plug cell body. So here you are observing, that is you need to insert the flat seating. So spark plug must be fitted with a metal washer. So here you are observing, this is the metal washer. Here it is shown inserted in between this cylinder head and this particularly body part. Why? Because I want to seal the combustion chamber and I want to remove the heat through this cylinder wall, that is a cylinder head, to this particularly spark plug towards this insulator. So if I am not utilizing this metal washer, then I can utilize the conical seat. The conical seat which I can make in the spark plug construction itself. So here there is no any washer required, as the plug is sealed by its conical seat. So no washer you are observing here. Then as far as spark plug temperature is considered, the ideal temperature of the spark plug tip, that is the central electrode and particularly the ground electrode, that particular tip, you are getting an average 500 to 850 degrees Celsius. If you plot the plug temperature versus the speed of the engine, then you will find this particularly graph. So during slow speed, your spark plug temperature is less. But as you are increasing the engine speed, the spark plug temperature goes on increasing. Definitely, because when you are increasing the speed, that means you are increasing the combustion rate inside the engine cylinder. So this particularly diagram shows the various regions of this particular temperature zones. If the plug temperature is up to the 400 degrees Celsius, then that particular range we are calling it as a carbon and oil fouling region. Wherein if the plug temperature, tip temperature is up to the 400, there is a possibility of carbon deposit over the spark plug tip. If the spark plug temperature is from 400 to 700 or 800, then this particular range we are calling it as a normal operating temperature range. If it exceeds from 700, that is 800 to 900, then there may be the possibility of oxide fouling electrode burning. The electrode of that spark plug may burn. And if the spark plug tip temperature goes more than 900, then there may be the possibility of pre-ignition. So these are the temperature zones which shows typical that is condition of the engine. Now if the tip temperature is low, just like this, then there is a carbon and combustion chamber deposit will not burn off. Whatever the combustion chamber, that is all the that is combustible mixture will not burn. So there will be the carbon deposit. If the temperature is very high, then the carbon, that is plug, may overheat, which may damage the electrode. Now, if we see the heat dissipation from the spark plug, if we see the heat dissipation from the spark plug, so this spark plug is now fitted over this particularly cylinder head. Now below that cylinder there is a combustion chamber. In that combustion chamber, if I am observing here to the tip of that 100%, so from that 100%, 20% this heat is absorbed by the intake fresh air. So whatever the intake fresh air coming in this combustion chamber, that takes the 20% heat dissipation. Then 58% heat is absorbed by the cylinder head walls. So the cylinder head as well as the cylinder walls, because surrounding to that piston and connecting rod, the piston, there is a cylinder wall. So cylinder wall and cylinder head absorbs the near about 58%. Now 20% heat is absorbed by this particularly the spark plug insulator. So this is the insulator. So top ribbed section and this insulator nose and all, this will absorb near about 20%, and 2% of the heat is absorbed by that particularly spark plug. So whenever you are going to design the spark plug wires, this need to be also taken into consideration. Now one can say that why we need to consider the operating conditions while designing any component. So component design will not be carried out, should not be carried out at isolated stage. So these interconnected requirements need to be taken into consideration when you are designing this particularly spark plug. Now, according to the spark plug heat range, we are classifying the spark plug into two major groups, that is hot spark plug and cold spark plug. So here you are observing this is the central electrode, this is the ground electrode, and this is particularly the nozzle, insulator nozzle. Now heat range, what is heat range? It is nothing but spark plug's ability to remove combustion chamber heat. Now heat range, this heat range is determined by insulator nose length, and this insulator nose length is shown here. So this is from the cell bodies. So cell bodies from this particularly up to this, there is a cell body. So insulator nose length is the distance from the tip of the insulator where it meets the insulator cell body. So this is particularly the insulator nose. So the heat range is determined by what is the length of that nozzle, nose length, what is the gas volume around the cylinder, that is insulator nose, and what is the composition of the insulator and central electrode. What is the material you are utilizing. That decides the range, heat range capacity. Now, as we seen, there are two types hot range. Hot spark plug. Hot spark plugs, here you are observing that the nose, insulator nose is longer. That means it will take long exposing a large surface area to combustion gases. So this longer area will dissipate heat slowly. And firing end heats up quickly. So this firing end here, whatever, it heats up quickly. This we are calling it as a hot plug. Now if you see the cold plug, this cold plug, now instead of this long nose, here you are observing the short nose, because from this point to this point, the tip to this, that is body shell, up to this is the insulator nose. So the insulator nose is shorter now. So as the length is smaller, it minimizes the surface area exposed to the combustion gas. Dissipated heats quickly, and firing ends heats up slower. So here you are getting the heats up slower. Now this is the difference between hot plug and cold plug. Now where to utilize the hot plug and where to utilize the cold plug. So again, this is another way to show here. It is shown not only the insulator nose, but connected to this here, it is shown. This particularly you are observing the water jackets. These water jackets in the combustion chamber. Similar water jackets you will find in the surrounding to this particularly, because below this there will be the cylinder and cylinder walls are there. So in the cylinder wall also you will find surrounding to that cylinder, you will find the cylinder that is cooling water jackets. So the heat, as far as hot plug is considered, there is a longer insulator. In cold plug there is a shorter insulator, and after that insulator the heat is directly driven to this particularly cylinder block, cylinder head, and then cooling system. Now where to use? If engine is driven continually at low speed, the spark plug may become carbon fouled. And for this, under this condition, a hotter spark plug may be required. So when your application requires the running of your engine at low speed continuously, then you can go for selecting the hot spark plug. But if you are requiring severe high-speed driving for an extended time period, then you need to use the colder range spark plug, because by using this you are preventing electrode burning from the excessive combustion chamber. That means in the racing cars where we are using continuously very high speed over extended time of period, we need to use the cold spark plug, isn't it? So apart from this regular spark plug, there are other different designs available in the spark plug. Some spark plugs have having the multiple ground electrodes. So earlier we seen only one central electrode and one ground electrode. So here you are observing two ground electrodes. Here instead of two, you are observing four ground electrodes. So this increase in electrodes, ground electrodes, provides multiple spark paths which reduces the spark erosion. And for particularly capacitor discharge ignition system, instead of maximizing, that is increasing the number of electrodes here, the whole circumference. So here at the center, you are observing the central electrode, and surrounding to this particularly you are observing, this will act as a ground electrode. So this surface discharge plug generally we are utilizing in capacitor discharge ignition system, which gives the good sparking even when found. Another one type of spark plug majorly we are utilizing is resistor spark plug. Here in this you are utilizing the spark plug with carbon compound resistor in center core. So here you are observing the resistance material. So this is the spark plug, this is the central electrode, and in between these two central electrodes we are having the resistance material. Why this resistance we are providing? This resistor suppresses the radio frequency interference, because during the discussion of EMI, electromagnetic interference and electromagnetic compatibility device, here in ignition systems we are facing the problem of your radio frequency interference. So one way of reducing this radio frequency interference is to use the resistor in this particularly spark plug. So you can have the non-resistor and resistor type. This is the non-resistor where you are observing the central electrode as it is. Here there is a ground electrode. But here in resistor type, here central electrode is not a single piece. So here in between that you are inserting the resistor, which will minimizes the radio interference problem. Now when you go for spark removal, you will first need to remove the lead from the each plug by using the rubber, because high tension coils, ST coils, you must have to remove. Then slacken each spark plug, and with the help of that spark plug spanner you can remove that particularly. But before removing that, you need to clean this spark plug by the brush, because over this spark plug there may be the deposition of debris, and after removing, cleaning this, you can remove the spark plug and you can place on the bench in the order, because this order, according to that order only, you need to fit it after cleaning and adjusting the spark plug gap. You need to inspect the spark plug gap. Now, by looking the spark plug condition, one can identify what is the condition of your engine, because you might have seen many road mechanics, they only remove the spark plug and they will see only the spark plug condition, and based upon that spark plug condition they will identify where the problem is, whether there is a problem in spark plug, whether there is a problem in ignition system, whether there is a problem in carburetor, because that will dictate the earlier stage combustion. So these are the various pictures of the spark plug conditions, which shows the various conditions. So if this type of the picture is there, then this is a normal use. If this particularly another that is some carbon, that is whitish carbon is there, then it is overheated. So here carbon fouling is there, this is a gap breachage, cracked insulation, then pre-ignition, glazed deposits. So by looking this particularly spark plug condition, one can identify what is the condition of your engine. Now, the spark plug gap is not perfect one. We have seen that it will affect the performance of the engine, performance of your combustion. So we need to adjust that particular spark plug. So before adjusting that spark plug, we need to measure, and this measurement between the spark plug gap, that is central electrode and earthed electrode, we are using this feeler gauge. Feeler gauge is the instrument by which we are measuring the gap, and if the gap is not as per the recommendations, then we need to adjust this by that is pressing this particularly electrode downward side or elongated. So this is the spark plug gap adjustment. This is all about the spark plug. Now, another very important component in the ignition system is capacitor. Another word is, we are terming it as a condenser. So this is the condenser, which you might have seen in various engines. Okay, that is ignition systems. This condenser we are fitting in this particularly cover. So capacitor minimizes arcing and hence speed up the collapse of magnetic flux. As the cam is rotated with capacitor disconnected, severe arcing takes place at the contact. So the major function of the capacitor is to reduce the arcing which is taking place at the contact, because of that arcing taking place in between the contact CB point you have seen, that is when we are making contact points on and off in the distributor, there will be the arcing, and this arcing will reduce the life of your contact breaker point, isn't it? So that particular we need to take care. If the contacts are open and induced electromotive force of 400 volt is generated in the primary circuit, and which causes a spark to jump across the contacts as they initially part. And this 400, we are jumping it in the secondary winding according to the number of turns. Due to the passage of this induced current in the form of a spark across the contacts, a gradual fall in the primary current takes place instead of sudden fall. So gradual fall of the current takes place, primary current. Now this arcing affects the speed of the coalesce of magnetic flux and quickly destroys the surface of the contact. A capacitor acts as a buffer device in an ignition circuit. The capacitor provides an alternative path for the surge current when the contacts have just parted. When just we are opening and closing, this particular capacitor will make the alternative path. Instead of jumping the small contact through the small contact gap, the current flows into the capacitor, charging it. After a fraction of the second, the capacitor discharges, but by this time the contact gap is too wide for the spark to jump across. So this is the capacitor here. We are having the hole here. This hole is required to screw for earthing. This is the symbol of the capacitor, and this is the connection given to the contact breaker point. A cylindrical type capacitor is commonly used with a coil ignition system, and it has typical capacity of about 0.2 microfarad, because capacitance we are measuring in terms of microfarad. It uses two rolled up sheets of metallized paper separated from each other by dielectric insulator. You have seen the construction details of the capacitor. You might have seen or learned it in the electrical technology. So not necessary to again repeat. So one sheet is joined to the earthed aluminum alloy container and other to an insulator terminal which is attached to the pigtail. Now, as far as numericals are considered, the capacitor which stores the energy, and energy stored in this capacitor is given by E is equal to half CV square, where E is energy stored in joule, C is the capacitance in Faraday, and V is the voltage in volts. So this is the formula. You have already seen these formulas in your electrical technology. Apart from that, the capacitance of this capacitor is very important. So how to determine this capacity of the condenser? It is given by the numerical formula, that is C is equal to 2 pi epsilon 0 epsilon R L divided by log R naught divided by R1, where this epsilon 0 and epsilon R are nothing but the permittivities. So what is that permittivity? Permittivity of the vacuum, that is the epsilon 0, which we are also calling it as a permittivity of free space. And this epsilon 0, it is a constant. As we are saying 2 is constant, pi is constant. So we are having the constant value, that is the 3.41 of the pi. So similarly, epsilon 0 is having the constant which is known as the permittivity of the free space, and its constant value is 8.84 into 10 raised to minus 12 farads per meter. And this epsilon r, it is the permeability of that particular material. Then L is nothing but it is the length of that particular wire or that particular material, and R0 and R1 are the internal and external radius. So these two formulas I have presented here. So based upon these two, we are now going for solving the different numericals. So first numerical, a condenser when charged to a potential of 2000 volts is found to be stored an energy of 24 joule. Calculate the capacitance of the condenser. Very simple example, might be asked for 2 marks. Now here what is given here, the potential that is 2000 volt is given, that means V is given, then the energy stored is given, that is E. E and V are given. We need to calculate the capacitance. So V is given 2000 volt, E is given 24 joule. Now we need to calculate the capacitance. So we know that energy stored in the condenser is given by E is equal to half CV square. So here E is known, V is known, only unknown is C. So with the help of this, one can easily, by putting the values in this respective formula, one can determine the C is 12 into 10 raised to minus 6 farad. Now this minus 6 is that is a larger number. So we need to provide this as a limit that is feasible one. So instead of 12 into 10 raised to minus 6, we can write it as a 12 microfarad. Okay, so this is a simple example based upon the energy storage capacity of the capacitors. Now second, a spark bridges the spark gap on application of a breakdown voltage of 10,000 volt. Taking circuit capacity of 50 microfarad, determine the energy released by the condenser. Now here voltage is given and the capacity is given, but this capacity in the given, it is not in the farad, so it is a micro. So microfarad means 10 raised to 6. So microfarad means 10 raised to 6 into 10 raised to minus 6. 10 raised to minus 6 into 10 raised to minus 6. So it will give 10 raised to minus 12. So with the help of this energy equation, E is equal to half CV square. Here you are getting 50 microfarad. So micro, that is 10 raised to minus 6 into 10 raised to minus 6. So it will be the 10 raised to minus 12. And whatever the voltage as it is. So you are getting 2.5 into 10 raised to minus 3 joule. So this is another simple example. Now somewhat different example, which is related to our automobile. An auto vehicle with 12 volt battery ignition employs an ignition coil having 500 turns in primary winding. The number of turns in secondary winding is 1600 times more than that in primary winding. So here it is very important to read carefully. Otherwise, many students, what they are terming, this is the number of turns on primary, this is the number of turns on secondary. This is not the case, because here clearly mentioned the number of turns in secondary winding is 1600 times more than that in primary winding, isn't it? So whenever you are going for solving the numericals, you need to read carefully what is the given data. So in the first part of this numerical, it is given 12 volt battery and the number of turns on primary and secondary. Calculate the voltage produced for sparking. So this primary voltage is given, secondary voltage is given, turns are given. So you can easily find out the primary, that is secondary voltage. Now further to that, how much should be the gap in its spark plug? Now to calculate that, we need to know what is the actual gap which is present in battery ignition system, because here it is required to assume certain data. We will discuss that later on. Estimate the capacity of the condenser. How much energy can be stored in its cylindrical if it is 40 millimeter long, 15 millimeter outer diameter, and 7.5 millimeter inner diameter. Its relative permittivity is 6.2. Relative permittivity is given, that is epsilon r is given. These diameters, that means with the help of that you can determine r naught and ri. This is L given. So we can use that particularly C is equal to 2 pi L into epsilon r epsilon naught, that particular relation. Now here first we need to determine what is the particularly secondary voltage. We are knowing that secondary voltage to the primary voltage is secondary number of turns to the primary number of turns. So here it is shown 1600 times the primary. So it is the 500 into 1600. So it will give the 19,200 volts, that is the secondary voltage. Now since this is the assumptions you need to remember. Since about 300 volts is needed for 0.1 mm gap. For 0.1 mm gap to produce the spark, it requires the 300 volt. This is the thumb rule. Now, if the secondary voltage is this much, how much gap is required? So we can calculate spark plug gap is likely to have 19200 divided by 3000. That means 0.64 mm gap is required. That is here. Calculate the voltage. How much should be the gap in its spark plug? So here we are calculating by considering, by assuming that about 3000 volt is required for 0.1 mm gap. So you are getting this. Now another assumptions you need to make, that is what is the epsilon 0. Epsilon 0 is not given because it is a constant and it is expected that its value should be remembered. So capacitance is we are calculating. So here if what is asked, how much should be the gap? Estimate the capacity of the condenser and how much energy, not only the capacity that is in the terms of the Faraday's capacitance, we need to also calculate the energy. So now for calculating the capacitance, we are utilizing 2 pi epsilon r epsilon naught epsilon r L divided by log r naught to the r naught by ri. So here epsilon 0 we are having that 8.854 into 10 raised to minus 12 Faradays per meter. And what is epsilon r? It is given already. L is known, epsilon r is known, r naught is known, ri is known, 2 pi it is constant. So by putting all this, you can get the output, that is 19.9 into 10 raised to minus 12 farad. So here minus 12 to make it microfarad. In earlier, that is one of the numerical we see. So here it is a 19.9 microfarad. So this is the capacity of the condenser. Now how to determine the energy? Energy we are calculating E is equal to half CV square. So we calculated this C. Now this C, it should be in Faradays. It should not be terming as a microfarad. So you need to take this 19.9. So here it is a 19.9. So correct it. It is not 19.0. It is 19.9. So half into 19.9 into 10 raised to minus 12 into what is the V secondary voltage, that is 19200. So by calculating this, you are getting the energy, that is 3.66 into 10 raised to minus 3 joule. So this is the energy of that particular condenser. How much energy can be stored? So this much amount of energy can be stored in the condenser. So likewise here we can solve various numericals based upon the condenser. Now another important component in the battery ignition system is ballast resistor. It will look like this, and it is fitted in between your primary winding and your battery. So it helps to regulate the voltage flowing in an electrical system to avoid overload or battery drainage, As the starter motor begins to crank the engine, it causes a significant drain on the battery. The ballast resistor allows the ignition system to operate at lower voltage until the engine starts. After ignition, the alternator begins to recharge the battery, restoring the regular voltage. The ballast resistor then functions to regulate the voltage going to ignition system to avoid additional wear on the system. So it is connected in series with the primary winding. It is present in between the ignition switch and ignition coil. The function of the ballast resistor is to prevent the overheating of the primary winding of the ignition coil. It is made up of iron wire, and iron wire has a property that its electrical resistance increases rapidly with a small increase in temperature. If the current from the primary winding flows continuously, the temperature of the ballast resistor increases, and this increases the electrical resistance. And this increase in electrical resistance will reduce the flow of electric current through the primary winding, and hence by reducing the flow of the electric current in the primary winding, it reduces the overheating problem of the primary winding. The reduction of current by ballast resistor prevents the overheating of the primary winding. Another one important component, it is a spark plug and ST lead. So spark plug ST leads. So this is the spark plug and these are the high tension leads. So these high tension leads carries voltage from the distributor to each spark plug, constructed using a conductor and an insulator. The conductor usually is made up of from your carbon, and insulator is the silicon. So silicon jacket is there. The conductor has an internal resistance in this particularly so as to reduce the radio frequency interference. In the spark plug also, in previous one of the slide we have seen that is there is a resistor spark plug which is required to reduce the RFI, that is radio frequency interference. The terminals at this end are protected by rubber boots. These are the rubber boots. So this is the distributor end and these are the rubber boots which keeps out the moisture and dirt away. Now if you go in detail, what is the secondary wires? This carries the very high current produced by the ignition coil, high voltage. So it is the solid wires. The wire conductor may cause radio interference, and to avoid this we are inserting the resistance wire, that is carbon impregnated strands and rayon. So the resistance generally which we are putting there is 10,000 ohms per foot, which prevents the RFI. And here you are observing the clips, so that these are the clips which secures the wires in place. So this red, and that is this particularly blue colors are shown as a wires, secondary wires. And if you go in detail, this is the secondary wire. These are the carbon impregnated strands which prevent the radio. This is the spark plug boot. Inside there is a metal. This is the insulator. Below that there is a conductor. So if this is the conductor, that is carbon impregnated strand. There is a rayon braid is there. Over that there is a conductive neoprene. Again there is the insulated rubber. Again there is a rayon braid. So neoprene jackets are placed. Why this particularly care is taken? Because through this particular conducting wire, very high voltage we are supplying, and the high voltage is in the range of 20,000 kilo, 20,000 volt, 30,000 volt. Even in electronic ignition system, we are going beyond that 40,000 or 50,000 volt. Biggest point in the ignition system is a contact breaker. So it is mechanical device which is used for making and breaking the primary circuit of the ignition coil. It has two metal points which is made up of your tungsten, and it is placed against each other. These metal pivots have a circular plate face about 3 mm diameter. Among the two metal points, one is fixed and other is movable. And this other movable, we are making this movable with the help of the movement of this cam. And this cam, once it moves, it will break or make the circuit. The fixed point, contact point is being earthed by the mounting it on the base of the contact breaker assembly. So this is the contact breaker plate which we have seen the placement is in the distributor housing. The movable contact breaker is attached to the spring-loaded pivoted arm, which is electrically insulated. The pivoted arm generally has a heel or rounded part which touches to this cam made up of some plastic material. The heel is raised on the cam driven by the engine. Every time when cam passes under heel, the contact points are forced apart and the circuit is broken. The pivoted arm is spring loaded, and in the case when points are not separated by the cam, it is held together by spring force and closes the primary circuit. And when the points are closed, the current flows through the primary circuit and it stops if it is open. So this is all about the various components of this battery ignition system. So what are the advantages of this battery ignition system? It provides a good spark at low engine speed because there is no any connection between engine speed and the spark which is occurring. We are providing the initial power, base power from the battery. So maintenance is also low. Disadvantage is in the battery ignition system, the battery is necessary. Without battery, we can't start our engine, and it becomes difficult to start engine when the battery is discharged. This occupies large space as we are utilizing the battery. The efficiency of the system decreases as the engine speed increases. Since the breaker point contact points are continuously subjected to mechanical as well as electrical wear, the contact breaker points required to remove or required to be taken care frequently. And applications almost in every vehicles, earlier vehicles, right from the light commercial vehicles to heavy commercial vehicles, cars, buses, motorcycles, etc. The battery ignition system was used. Now this system is being replaced by some of the advanced ignition system, that may be electronic ignition system, distributorless ignition system likewise. So here we ends this battery ignition system. So we stop this.